fizzled example of a gamma-ray burst, the most powerful kind of explosion known in the universe, suggests these outbursts may not always work the way that scientists thought. And that versions of these flares can be surprisingly brief, researchers say. A typical gamma-ray burst unleashes more energy in a few milliseconds to minutes than the Sun is expected to emit during its entire 10 billion-year lifetime. Astronomers classify gamma-ray bursts as long or short based on whether the outbursts lasts for more or less than 2 seconds. Previous research suggested that short gamma-ray bursts result from the mergers of two neutron stars, which are the extraordinarily dense stellar corpses formed by the collapse of massive stars. In contrast, astronomers thought that long gamma-ray bursts are linked to a catastrophic explosion known as a supernova, one resulting from the implosion of a giant star. Now scientists have discovered a short gamma-ray burst that formed the same way that long gamma-ray bursts are normally thought to, from a single giant star's demise. Dying stars also produce extremely short gamma-ray bursts. Thomas Awamada, an astrophysics doctoral student at the University of Maryland and NASA's Goddard Space Flight Center in Maryland and lead author of a study on the newfound gamma-ray bursts afterglow, told Space.com. Scientists focused on a gamma-ray burst dubbed GRB200826A, which originated in a galaxy about 6.6 billion light-years away in the constellation Andromeda. The blast lasted just 0.65 seconds, although after traveling for eons through the expanding universe, this signal had stretched out to about 1 second long when it was detected on August 26, 2020, by NASA's Fermi Gamma-Ray Space Telescope. Other spacecraft also spotted the burst. NASA's WIND mission, which orbits a point between Earth and the Sun located about 930,000 miles away. NASA's Mars Odyssey, which has been orbiting the red planet since 2001. And the European Space Agency's Integral satellite that launched in 2002. When astronomers saw the gamma-ray burst and decided to follow up on the event, they expected to find signatures of a collision between two neutron stars. But that's not what scientists saw at all. Using the 8.1-meter Gemini North Telescope in Hawaii, scientists analyzed the gamma-ray burst's host galaxy 28, 45 and 80 days after the explosion was first detected last summer. These observations revealed that after the burst's afterglow faded away, it brightened again. This rise in energy came from the supernova that happened after the implosion that caused the gamma-ray burst itself. The data and image analysis was very challenging, as we needed to separate the light of the supernova from the light of its host galaxy, Awamada said. This discovery was particularly surprising as this was actually not what we were looking for, Awamada explained. He and his colleagues are analyzing data from the Zwicky Transient Facility at Palomar Observatory in California to look for binary neutron star mergers that are thought to produce a short gamma-ray burst. Instead, the scientists found the kind of aftermath one would expect from the explosion following a collapse of a massive star. We found a star that died, Awamada said. Scientists had previously known that some gamma-ray bursts from imploding stars could appear as short gamma-ray bursts. But astronomers had thought this was due to the limitations of the instruments used to detect such events, according to Binbin Sang at Nanjing University in China and the University of Nevada, Las Vegas, lead author of a study on the gamma-ray data. This burst is special because it is definitely a short-duration gamma-ray burst, but its other properties point to its origin from a collapsing star, Zhang said in a NASA statement. Last year's detection is the shortest known gamma-ray burst powered by the death of an imploding star. The researchers suggest that it and other supernova-driven gamma-ray bursts appear short because the jets of gamma rays that blast out from the collapsing star's poles are not strong enough to completely break through the star's outer envelope. Most other collapsing stars have such weak jets, they do not produce a detectable gamma-ray burst at all. We think this event was effectively a fizzle, one that was close to not happening at all, Awamada said in a statement. Even so, the burst emitted 14 million times the energy released by the entire Milky Way galaxy over the same amount of time, making it one of the most energetic short-duration gamma-ray bursts ever seen. This discovery may help solve a long-standing mystery. Although previous research connected long gamma-ray bursts with supernovas, astronomers have detected far more supernovas than long gamma-ray bursts. The discovery of a short gamma-ray burst linked with a supernova suggests that some supernova-driven gamma-ray bursts may be masquerading as the short gamma-ray bursts previously thought to be created by neutron star mergers, and therefore not getting counted as the supernova kind. In the future, finding more short gamma-ray bursts like this one could help explore different progenitors of these explosions, as we are not entirely sure how this event could have been generated. Awamada said. The scientists detailed their findings in 2 studies published online on July the 26th in the journal Nature Astronomy. Be sure to leave your questions and answers in the comment section below to grow our community, and don't forget to subscribe for more videos.